notes. So again, finish up copying the guidelines and we'll start with example 1. Josie, let me know when you're done copying the guidelines, okay?
No, I'm not.
You're not? Okay, can you let me know when you're done, bud?
Because I write really slow and got really tired after writing.
That's okay, I got you. Ava, can you help us with instruction for examples 1 to 5, please? Awesome. Okay. Number 1 says x minus 3 students divided by 2. Divided by x plus 2. Then multiply by x squared plus 5x plus 6 divided by x squared minus 9. Guys, the guideline said we only flip the second fraction if what? If we're dividing. Are we dividing on example 1?
No.
No, so we don't. Step number 2 said do what? Factor. All right, let's factor, y'all. X minus 3. Can we factor that at all?
No.
No. X plus 2 in the denominator? No. Yes or no? So we just copy those down. All right, now factor out the x squared plus 5x plus 6 and factor out x squared minus 9. Everyone factor those out. If you need scratch paper, side work, do it on the side. Tack, give me the factors for the numerator when you have them. And then Levi, give me the factors for the denominator if you have it. X minus 3, x plus 3. Tack, one. Numerator, okay? When you're... If you know how to find restrictions, because that's the next guideline, remember, restriction before cancellation, and go ahead and execute that.
X plus 2 and x plus 3.
X plus 2, x plus 3. Great job. Okay, let's find the restrictions. Okay, what do we need to do to find the restriction?
No, said everything equal to 0?
Not everything, just what things? Top or bottom? Numerator or denominator?
I think all denominators.
All denominators, okay? So guys, to find restrictions, we said all denominator equal to 0 and then solve. As you can see, when you set these equal to 0, we have x, even though we write x equals to -2, but when we write the restriction, do we write equals, guys? No. We go and write what? Cannot. So restrictions are x cannot be what? -2, comma, 3, comma. Right, we need to box that up because that is, okay, now we can, this is my favorite part, y'all. We get to do what? We reduce, okay? So can we reduce the x plus 3 and x plus 3?
Yeah.
Binomial with binomial. What else can we reduce? X plus 2 and x plus 2. What else can we reduce? Oh my, is it 0? 1. Guys, each time we reduce, it's like dividing, right guys? So that means when we divide and make the same, we get 1. 1 over 1, it's just then what? 1. Look at that, isn't that beautiful?
Does 1 have restrictions?
Does 1 have restriction? Can 1 ever be equal to 0? No. You can give me $1 and I will give you nothing back. So not fair. All right. Let's do this number 2. 4x minus 2x squared divided by 2x squared plus 2x minus 15 times x squared minus 4x plus 3 all over 2x. Step number 1, what should we do? If it's not dividing, then what do we do? Factor it all out. Okay. So the first numerator, what do they have in common? So take out the 2x. What's left? What's left? 2. Minus what? X, all right? All over. You're going to need to factor that out. This one is kind of like 2 times x, which is 2x, right, guys? All right, your job is to factor out that trinomial. So, Corey, whenever you have the denominator for the first fraction, let me know. Chelsea, you are in charge of the second numerator. Everyone else, work it out as well, please, so we can double check Corey and Chelsea. You got it? All right. What's your numerator factors? X minus 1 times x minus 3. Good job. 2x plus 5 times x plus 5. Like that?
No.
No?
Because I think it's like, it's supposed to be like a negative 15.
Yeah? So what are the factors, guy? Okay. Will you make the chart, right? Any GCF at all? No? Okay. What's A, what's C? 2 times? Which is? Negative 30. What's your B value? 2. If you can't find the combo, then is it factorable? No, okay. Would you guys agree that 1 times 30 is not going to work? 2 times what? Is it working? 3 times what? Is it working? Is 4 going there? 5? Is it working? No. 6? 6 times 5 is the same, right? 7? You don't have anything. So is it factorable? Yeah, don't force it, okay? All right. So we have 2x squared plus 2x minus 15. Okay, so now, before we go and cancel, which is my favorite part, we have to do what? State the restrictions. We do take each denominator, students, and set it equal to? But guys, it's not factorable. So how do we solve for x when it's not factorable? Cry?
Imagine.
No, we don't know that yet. Quadratic formula. X equals negative b. What is our b value, Shay? Shay, what's your b value? 2. So negative b plus or minus square root b squared. So that's going to be 2 squared minus 4 times. Slater, what's our a value? 2. Margot, what's our c value? Negative 15. All over 2 times 2 because our a value is 2. Then we, from here, just work out the basic math. Under the radical, Dexy, what is 4 times 2 times negative 15? Oh, let's do this, Dexy. Can you do negative 4 times 2 times negative 15? Okay, get a calculator. $120. Okay. Do you guys agree? Yeah. Okay. And then Dexy, what's 120 plus 4? 124. Good. So negative 2, student, plus or minus 124 all over 4. If under the radical we have a positive number, is that imaginary number or real numbers? Real. So we can have something that we can exclude. We do need to simplify 124 though. Hey, Dexy, can you do me a favor? Can you divide that by 2? What would we get for 124 divided by 2? We need to simplify this out. 124 divided by 2 would be what? 62. Divided by 2 again? 31. Guys, why did we divide it by 2 and 2 again? What's the purpose of dividing by 2 and 2 again? How do we simplify radical? To simplify radicals, how many identical numbers would we need under the radical itself? 2. If we have a pair, then it can be what? Taken out, right guys? Yeah. All right. So x equals negative 2 plus or minus 2 rad what? 31 all over 4. Can I simplify some more? Yes. On the numerator, we can factor out a what? 2. So when we factor out 2, what's left over on the numerator? Negative 1 plus or minus what? Yep. Square root of 31. Or 1 square root of 31. Is that the same, students? Yes. On the bottom, we have 4, but 4 is really 2 times 2. So we can cross that out because we can reduce. So we have this x value, which can I say not equal? Is that the same thing? Yep, x cannot equal 1 plus or minus square root of 31 over what? 2, okay? That's from that first piece. Now we have to go and find the restriction of the second denominator. What is the second denominator, Susie? Yep, 2x. We're going to set it equal to 0. Jackson, how do we solve for that x? Divide by 2. So 0 divided by 2 is 0. So students, I'm going to add that on to our not equal. Right, guys? So right now, we have how many values that we must exclude? So close, not 2, but 3. The plus and minus makes it 2 itself, and then the 0, okay? So that's just excluding the value, which is probably more difficult. Whoa, it disappeared, y'all.
No, there's too many, it's too many space. I used too many space on the paper.
That's okay. All right. So now we are going to go and cancel. Can we reduce, students, the 2x and the 2x?
Yeah.
Great. Is that all?
No.
No?
Yes. Not yet.
Is that all we can cancel? Yes, that's it. So, guys, then here we're going to put them all back together. 2 minus x times x minus 1 times x minus 3, all over what, students? All over 2x squared plus 2x minus 15, and we box that up. We also need to box up the restrictions, which we did. So both of these must be boxed up. All right, example 3. Can you guys do me a favor and see if you can factor everything? Oh, I'm sorry. Example 3. Before we factor, what should we do first? Well, yeah, but we're going to wait for that. But let's factor first. And the reason I want to tell you is this. We have to find the exclusion twice. Before we flip and after we flipped, okay? So, okay. Okay, numerator. Factor that out. Audrey, can you help me factor out the numerator, please? The first numerator. Take out what? 2. What's left? Great. All right. And now, Nolan, you're in charge of the first denominator. The second numerator, before we flip, we have x plus 3. That's as far as it's going to go. Savannah, you're going to be in charge of the second denominator. So go ahead, guys, factor that out. The rest of our class, do it on your own paper. Once you're done factoring, we have to state the restrictions before we flip and after we flip. So when it's a division problem, we have to state it twice. Unless it repeats, then we don't need to write the repeating exclusions. Okay? Savannah, you got it?
Yeah.
What did you get?
X plus 2 and x plus 1.
Great. Nolan, you got it?
Yeah.
Okay, what do you get?
X plus 2 and x minus 1.
X plus 2, x minus 1. Confirm?
Yeah.
All right. Guys, before we go further, first x, what is it that x can never be? -2. The second x, what is it that x can never be? 1. Is this going to give us a repeating restriction? Yeah, so if it's a repeating restriction, do we need to state it again? No. You can write it, but when we box it up, we're not going to write that value twice. Does that make sense what I'm saying? This one right here, what is that x can never be from that last one? -1. Now, we are going to multiply by the reciprocal. So now, we are going to flip. First fraction or second fraction? Second one. Okay. So, multiply x plus 2 times x plus 1 all over x plus 3. Now, this is the part where we said we need to write the restriction again. What is the new numerator that we have? X plus 3. So we have to exclude -3. So right now, let's box it all up before we forget. What are all the values that x cannot be? -2, comma, 1, comma, -1, comma, -3. Notice how we don't write -2 twice, okay? All right, this is the fun part. Let's reduce. Kayla, what do you want to reduce first? X plus 3. Yes, I agree. Daniel, next.
X plus 2.
X plus 2. Sean, is that all? Or can we reduce some more? That's it. Let's put it together, Sean. What's the final answer? Yep, box it up. So how important is factoring? Oh, yeah. Yeah, it's okay.
Is it okay if I do all the simplified first before finding the restriction?
Sure, of course. But remember, before you reduce, you got to state the restriction. So if you forget and if you cancel it and you're like, oh, it's already canceled, I don't need to state the restriction, then that would be wrong. So just be mindful, okay? Bless you. All right, Talia, let's go. Number 4. Can you factor out that sum of cubes for me, Talia? So everybody factor out the x cubed plus 27. Just that way we can back up with what Talia is about to give us. And then the second numerator, Tamer, factor the second numerator and give it to me when you're ready. Tamer? Beautiful, good job. Tyler, you got it, honey?
I think so.
Okay, yeah.
X plus 3.
Uh-huh. Minus 3x plus 9. Okay, great job. Okay, let's state the restriction before we flip. First restriction over here. X can never ever be what, Calvin? Negative what? You said 3? Yeah. Okay. Katie, second restriction over here. X can never ever be what? No. You said equal to 0. So that right there is x can't be 0. Then we are going to flip. Now, can you guys see that before we flip, we can also reduce the x plus 3 on the top and x plus 3 on the bottom? That's okay too. Okay. You can reduce. And then now we will rewrite. By the way, if we reduce, what's on the denominator now? 1. We will multiply by its reciprocal, which is x squared times x plus 1 all over x. Oh, I didn't flip. Can you guys see I didn't even like switch? Sorry. It's x squared times x plus 1. Okay. We have to state the new restriction. If we have x squared, guys, and we take it and set it equal to 0 and solve for x, what would that be? 0. So do we already have 0 though? Yep. And then x plus 1 set equals to 0. What does that x come out to be? Negative 1. So let's write the restriction. Can we reduce any more after we flip? Check it out. Yes. We could have reduced that before we flipped, but now that we flipped, what can we reduce? We have an x here and we have x squared there. So if we reduce, what's on the numerator? 1. What's on the bottom? Yep. So we're gonna say, oh yeah, that is now 1. This is now an x. So on the numerator, what do we have on the numerator? Shaheen? Yep, 1 times what? Yep, x squared minus 3x plus 9. So 1 times anything is just that, right? And then the denominator, Shaheen, what do we have? 1 times what? X times x plus 1. We will box that up. Now we are going to put all the restrictions together. X cannot be what, Sadie, in this question? 0, negative 1, negative 3. Box that up. Remember, we have to box up our restrictions along with our finalized answers.
I feel like my brain jumbled while we find the error.
Malia, how many more examples do we have? 2. Good job. Let's flip it over. Oh my. Woo!
What in the world is number 5?
I love you too, Kane. All right. Okay. Guys, a fraction bar is just simply a what? A division. Okay? So, we will first rewrite this as a simpler division. Okay. Now, normally too, if I'm rewriting this anyway, I tend to rewrite things in descending order. What does that mean? What does it mean by descending? Yeah, high to low, right? Like things are decreasing. So if you guys look at the first numerator, this has a power of what? 1x. This has a power of no x. Would you guys agree? Yeah. So when I tend to rewrite it in from the highest power of x to no x, if possible. Okay, and I'm going to rewrite horizontally with the division sign like that. What's the second fraction? What are we dividing? 5x minus 15. You're right. On the bottom, can you see that you have an x times y squared? Right. Let's state the restriction. We can factor. Let's factor first. All right, Carter, on the numerator, we have negative 2x plus 6. If it's negative, Carter, we will take out a negative number. So what is the negative number that we will take out in the first numerator? And what's left, bud? Great job. This is now over x to the third divided by, Nick, second numerator. What are we going to take out? 5. What's left?
X minus 3.
X minus 3 all over x times. By the way, y squared is just y times y, right, guys?
Yeah.
Yeah. All right. Let's state the restriction before we flip. Diego, first numerator of x to the third. If we take x to the third, set equal to 0, what is it? X can never ever be. Yeah. Perfect. This is also x equal to 0 here, but we already have it. Would you guys agree? We have y squared equals to 0. So Andrew, what is it that y should never ever be?
0.
Perfect. Okay. Let's flip.
It's all 0.
Right now it's all 0. Okay. Now this is x to the third times x times y squared. If you guys want to put it back, or you guys can write it out over x times x minus 3. What is, Roxy, the new numerator? I'm sorry, the new denominator that we just got by flipping? We multiply by the reciprocal, so that means we have a new denominator.
It's 5x minus 3.
So we have to state the new restriction. What is it that one cannot have? X. So, guys, let's reduce. Roman, help me cancel. This is my favorite part.
Negative 3.
Say that.
Or x minus 3.
Right. The whole binomial's got to go. Okay. Now, anything else, Josie, that we can reduce? Look at it again. Remember what the x's. Okay. So this is now just 1, and this is how many x's left, Josie? 2. Good. X squared. So now, look at it again. Anything else before we multiply horizontally? Yes or no? Nope. All right, let's multiply horizontally. So that means, guys, this is a negative 2 times what? Y squared. Over what? X squared times 5, but we normally write the number first. So it's 5 what? X squared. We will box that up, but then we will also need to box up the restrictions. Give me all of the restrictions. X cannot be 0, comma, 3. But y cannot be 0. Box that up. All right. Last one, y'all.
We have an area problem.
We have an area problem. How do we find an area of a rectangle? Length times width. So we multiply. Okay. All right. Our length is 8v minus 56 all over 8v plus 48 times the other side. V squared plus 9v plus 18 all over 8v squared plus 24. Have we seen these kind of problems before? Yeah. Yep. What should we do next? Factor. You are right. Roman, give me the first numerator in factor form.
Oh, what is it? 7.
Take out.
Take out. Oh yeah, take out an 8.
Good.
And then it's b minus 7.
Good.
Yeah.
First denominator. Can you please, Diego, tell me if that's factorable or not?
Yeah.
Yeah. What are you going to take out?
8.
Okay. What's left?
B and 6.
V plus 6. Okay. Multiply. Okay.
Oh.
All right.
Oh, I must have looked wrong.
Oh, that's okay. Katie, go ahead and factor the first numerator. And then the tamer, you're going to factor the second denominator. Okay, tamer.
I got 8v.
8v.
V plus 3.
V plus 3. Thank you, sir. So, Katie, whenever you're ready, huh? Yep.
V plus 3 and then V plus 6.
V plus 3, V plus 6. You guys agree?
Yeah.
All right. Let's take the restrictions. Guys, we do take each denominator and we set it equals to 0. But does it make sense to say 8 equals to 0 ever?
No.
No. So that's why when it's a constant, we don't have to worry about it. But for this one, V cannot be what?
Cannot be negative 6.
Good. 8V equals to 0. So what is it that V cannot be? Well, the other side is negative 3, but how about this one? 0, right? Now, this is where I think you said negative 3 came from, right, Kevin? Okay, so 8. Okay, so we got those 3. Now, can we reduce Kevin at all?
Yeah.
Oh, yeah, tell me, what?
V plus 3.
V plus, okay. Anything else, Kevin?
V plus 6.
Great. Anything else, bud?
And the 8.
Oh, yeah. Anything else? No, all right. Multiply horizontally. What should we write down for our final area? V minus 7 divided by 8V. Box that up. And then, Calvin, what are all the restrictions that we have to box? Comma. Comma. Is that all? Yes. Good job, bud. And students, that is the end of 4-2.